All right, good old Kenzie. She's saying when I multiply these two radicals, I get this radical here. Is she correct or not? First thing, some of you guys may try to store in a number to see if she's right or not. You can't. Anybody see the word that is coming up here that says, no storing here, Dylan? Darn right. Anytime I see algebraically, unfortunately, I got to do this all out. Good idea, though, to try to store a number in, but it's not going to be valid if you try to do it. All right, so first time we're reviewing this here. Anytime you see a radical with another number inside, this is called the index, by the way. Like 7's the index here, 5 is the index here. I want to try to rewrite it as an exponent, fractional exponent. An exponent, that's a fraction. All right? So I can rewrite any radical as an exponent that's a fraction. How does it work? I'm going to put an E here. That's exponent. E for exponent. And this is called the index, just like I showed index. I'm going to put an I there. How do you convert it to an exponent? Ready? E over I. E over I. That's how it works. When you want to rewrite it as an exponent, that's a fraction. E over I. And this really killed me a couple days ago when I showed this the third period. Anybody? Rapper Nelly? Yeah. Somebody? Yeah? Because no, like crickets in period 3. No idea who I was talking about. Nobody? Hot in here?
Yeah.
Yeah. Yeah? He sang that way. He was like a solid early 2000s to 2010 rapper. Collaborated with a lot of others. He wrote a song, a highly inappropriate song, but he wrote a song called EI, and that's how I always remember it. All right. The verses in there, he's always like EI, EI. I'm not going to get into it. All right. But that's what I think about. All right. If you ever hear it, you can think of Algebra 2. All right. Highly inappropriate song, though, but EI. All right. Exponent over index. So go back to the top here. How can I rewrite the 7th root of x squared? X to the exponent over index. 2 over 7. Those things are the same. And what about the 5th root of x to the 3rd?
3 divided by 5.
Exponent over index. There you go. X to the 3/5. And what am I doing to the 2? What's the operation in between?
Greatest common factor.
What?
We need to have a greatest common factor.
What? Stop. Easy. What's the operation between the 2? What am I doing to the 2? I'm asked to what? Oh, yeah, multiply them. All right, so we're going to multiply them. Anybody want to dig deep from your exponent rules now? If you have the same base and you're multiplying, what do I do with my exponents? There we go. I add them together. When you multiply with the same base, you add your exponents together. So this is going to be x to the whatever 2/7 plus 3/5 is. And thank goodness we have calculators. I add the exponents when I multiply them. And that's going to be x. What's your calculator giving you? 31 over 35. So is she correct? I don't know. Can you put it back into a radical for me? 31 over 35. That's the same as this. X underneath. What's it being raised to? E over I.
31.
31. And what's your index here?
35.
35. So is she correct?
Not correct.
She is not correct. And this is how we're showing it. E over I to go back and forth. E over I to rewrite them. Questions? I know I just at least one. I don't have time. You guys know this. 2.5 weeks is not enough time to go over a year and a half. Just I wanted to expose it. So. All right. Questions? Because I'm rolling. Okay, 31. I'm about to get fired up because this is like the fifth, sixth time we've seen a recursive question. 31. Write a recursive formula for that sequence. And this is driving me nuts because I've been working with a lot of people. All of a sudden, they just go to the formula sheet. There is nothing on the formula sheet for recursive. Recursive has nothing to do with geometric or arithmetic either. Recursive is like a standalone all by itself. The thing you guys got to remember about recursive, it comes in two parts. Okay? This has nothing to do with geometric or arithmetic, so stop looking at the formula sheet. You got to do this on your own. The first part can't get any easier. You just tell me what the first term is. It can't get any easier. The first part of a recursive formula, you tell me, in this case, is 6, but you got to write it with the correct notation. You just can't write first term equals 6. How do I write first term in our notation? A with?
A1 equals 6.
A with the subscript of 1. Remember that? First term is 6. All right, now you do have to do a little math. The second part of a recursive formula starts out with an, which basically means any term, an, equals, now you got to write the previous term. Anybody remember the notation of previous term?
An minus.
Tim, A with a what?
A with the n minus 1.
There is previous term right there. And now you have to figure out what you're doing. Find the rule. Everyone, 6, 9, 13.5, 20.25. I do this to 6 to get to 9. I do this to 9 to get to 13 and a half. And it better be the same rule every time. Don't tell me add 3. That's not the rule. It's got to happen every time the same way. So what are you doing? Jake?
Multiplying by 1.5.
Multiply by 1.5. Now, how you show that? Look, could I do this?
No.
That's fine. That's acceptable. I could also do this. Put the 1.5 out in front of the an minus 1. That's fine too. But I need that notation there. And that's it. That's your recursive formula. Here's your 2 points. Congratulations. Road to 28, here I come. Might be 30, 32 as well. Don't bank on 28. Okay, recursive has nothing to do with your formula sheet, nothing to do with arithmetic or geometric, even though this formula is geometric, right? A1, an minus 1. Great. Oh, we love these diagrams, right? 32. We're going to see it again. You're going to see it on Thursday when you open the packet and you flip through. You're going to see this diagram there. The old dot plot. Oh, good old Robin flipped a coin 100 times. It landed 43 times. Heads 43 times. Is it unfair or not? All right. Hey, before we do this, nobody cares about your opinion. So don't write it down. Well, it did land 43 times, which is almost halfway. So I'm going to say the coin is fair. No, you're not. Nobody cares about your opinion. Don't write it. Give me some numbers, please. Give us some numbers so you can create a valid opinion. All right, just don't start writing a nice little essay about coins and, well, it might be weighted. Stop. Okay? Based on my graph, stop. Give me some numbers. All right? What numbers in particular? I know you don't see 95% here and it's not being asked, but I want the confidence interval. So you can tell me where 42 fits in. Confidence interval. Got to know it. You know it's going to come up. You're going to be asked to find it. Mean plus or minus margin of error. If you just want to, right here, mean, and what's margin of error again? 2 times?
2 times 0.0.
Standard deviation. And you're given them right there in the left-hand corner. Guys, I don't feel any sympathy if we don't roll in next Thursday knowing how to use this. You know it's going to come up, and you're going to have to use it. .499 plus or minus 2 times 0.049. Subtract them to get the lower value, add them to get the upper value. And then we'll talk about Robin's coin. All right, here's your 95% confidence interval, 0.401 to 0.597. Hopefully we got that. And let's go back, 43. Where's that fall? Inside or outside?
Inside.
Inside, right? So fair, unfair?
Fair.
Fair. It's got to fall outside for it to be unusual or significant. If it's inside, who cares? You're just like the other 95% of people. It's fine. Give me a number of flips that would be unfair. 32 flips. 63 flips. Right? That would be outside my interval. But this coin is fair. Explain, because it falls within the confidence interval. Done. Again, nobody cares about your opinion. You got to have numbers to back it up. Done? Anything? All right, last one. And darn it, I wish we did more and more of these, but you guys know with the time we couldn't. These directrix parabola questions. Get out your formula sheet, please. Look at number 10 on your formula sheet. All right, look at number 10 on the formula sheet. The formulas you got to know. That's what I'm talking about. Formulas you got to know. Look at number 10. Wish we did more of these. Everyone's got 10, equation of a parabola. This is what it's asking for. Determine the equation given the focus in this directrix. All right, let me write out the formula first. That's on your sheet. Y equals 1 over, I told you to put the P on the bottom, correct? Yep, most of you have it on there. 4P times X minus H squared plus K. Let's first start with H and K. Everyone see what that is on your sheet? That's the coordinates of my, read the sheet here, number 10. That's the coordinates of H and K. Vertex. Does the problem give you the vertex? No, so let's discuss how to find it then. It says the graph, use of the graph is optional. I'm using it right now so I can show you this. All right, let me graph what's called the focus for -1. Everyone all right if I just call it point F for focus? Directrix. What's the directrix? That's not a point. Directrix is a line. Directrix is a line, not a point. So I'm going to draw a line, horizontal line, going through -5 on the y-axis. 1, 2, 3, 4, 5, I think. 1, 2, 3. Yep, there it is. The directrix is a horizontal line, not a point. Horizontal line. All right, you guys dropped some knowledge from last year. I said I needed the vertex. Anybody remember where the vertex was in comparison to the focus and the directrix? Halfway between them, everyone, right? Halfway. Go ahead, put a point halfway between them. Put a point halfway between F and, count them up. How far apart are they? 4 units. Go 2 units either way. And there is your vertex. Maybe I'll put a V there. There you go. There's your vertex. Can anybody, now I need the coordinate so I can plug it in. What is the vertex? What is that point right there?
4, negative
4, comma,
negative 3.
-3. There we go. H, K. H, K. That's the coordinates of your vertex. Plug it in. I'll get to P in a second. So ready? X, what's your H value?
4.
Minus, what's H?
4.
4 squared. And what's your K value?
Minus 3.
K value is -3. You can do plus -3 if you want. You can write it like that. That's fine. No one's going to hurt you there. Or you can write -3. It's up to you. You don't need to do it. Don't try to double distribute. That's it. Leave it so we can get to the P value. Are you all right? How the vertex halfway in between? We're okay there? Halfway in between. H and K are the vertex. All right, now what about this P value? Look back at your sheet. I don't want to tell it to you. What do I plug in for P?
Distance, focus to vertex.
Focus the vertex. How far apart are they? 2. So I'm going to plug 2 in for P. So my fraction's going to be what? 1 over 8. 4 times 2. Whoa. Maybe that's how we leave it. You guys did a great job. Only thing I have to worry about is, should that 1/8 remain positive, or should I put a negative in front of it? All right. Here's how I figured that out. You guys remember parabolas open up one of 2 ways. They can smile or they can frown, right? If they smile, it's positive out in front. And if it's frowning, it's a negative out in front. I know that's elementary schoolish, but it's a good way to remember. Anybody know how I know if this is going to smile or frown? You know, Jake?
Well, kind of, I guess.
Oh, go ahead. Explain.
Because the V's under, and then there's the Y5, so it's going to be facing the Y5, right? Because it goes to like the
So should I go up or should I go down here?
down.
No.
No.
Nope. Opposite. The parabola always goes away from your directrix. Never crosses. It's always drawn away from the direct. Never crosses. Right. So if this is my directrix, it's got to be drawn away. So do I leave this positive or put a negative in front?
Positive.
There it is. There's my answer. Okay. Always drawn away from the directrix. If I frown, you just put a little negative out in front, and that's it. You're to adjust it. All right. There you go. 33, 36, 37. Right before class ends, I'll let you